All right, guys, welcome back. Appreciate your patience throughout the day. We're going to get back on schedule here. It's really awesome to see everyone coming out for these types of events. As I mentioned earlier, if you're just out coming in, my name is Daniel Allen Jones. It's an honor to be able to represent the City of Edinburg's UFO Festival and Conference here. For those of you on social media, if you're on Facebook, we have a Facebook group called the Texas UFO Network. There are over 5,000 people on there. They check out sightings, they check out what events are going on, they share about news, they share about things that they've seen, they take pictures that they don't know. A lot of people do post things like Starlink, and that'll continue to be a challenge for those who aren't familiar that is out there. And one of the things I think that really helps out is having someone with a scientific background, an astronomical background, to really help shed light on some of the things that people are seeing up here in the skies. We live down here, you guys are local, right next to NASA, you've got SpaceX, all these things people are going to still see for many years probably to come and still wonder what's going on despite them being around for a while. Our next guest speaker has an interesting background in astronomy. He's looked at this in a scientific way that helps us understand what we're seeing. A lot of people are unfortunately not very good at identifying things. And so UFO is a very subjective term. To you or me, if I see something and I don't know what it is, it might be unidentified to myself, but maybe one of you out there might say, oh, that's a satellite, that's an airplane. Or whatever it is, maybe it's swamp gas. Or maybe it's an alien spaceship. So it's something that we're trying to understand. There's a lot of ways to analyze photography, photos that people submit. So Marc has been part of MUFON. He's analyzed photos. He's an astronomer who uses what he knows in the scientific realm to try to apply what we can to really use discipline and understanding that there's a lot we can learn from looking into these subjects. He's also taking part in a lot of things that, where you've seen him on different shows and things. He's talked about how things like MUFON, they take reports, we get a lot of information and data from groups like that, and we try to analyze this in a way that we can figure out what we're dealing with. And sometimes UFOs are very mundane. Sometimes they are misidentified objects, and it does happen a lot. But maybe there is something more to the percentage of reports that are still unknown. And it's really good to have people like Marc to be able to analyze that. And he also has an observatory in Arizona where he does live tours called the Sky Tours. Maybe tell him a little bit about that. I've had the honor of knowing Marc for a few years now. We were just in Roswell where he did a presentation. He makes it very interactive, and I hope it's going to be important for you guys who are trying to know and learn about the universe, and also the possibilities of who else is out there, and if they're coming here. So he's also an author now. He's written a book called The Populated Universe, and I'm really excited to bring him to the stage for the first time here in Edinburg. Please help me in welcoming Marc Antonio. Marc.
Okay, thank you. All right, thank you, laughing for that. Yeah, I'm an astronomer, and this is what we look like. I started that observatory that Daniel mentioned in Arizona because I thought it was important to bring science to everybody. I'm very much someone I'm very much someone that's very much into educating people and bringing them along. Because sometimes people don't get science, and it's usually because they don't have a chance to understand it, not given a chance to understand it. So this particular talk is going to show a few things. It's going to show you a little bit of our culture and backdrop of alien, intervention on our planet. And then we're going to actually talk about the physics at a lay level of how they can actually be here from so far away. And guess what? They can. They can. Now, I'm not the only one that says it. There's a lot of people that are saying that. A lot of people in science. So the talk is called Light Years to Earth. And when we talk about our planet, right, our planet is a beautiful blue, brilliant beacon in the night sky. And it's also one for other people. So the question is, we look, is it possible that we're alone? Okay, have we been visited? It's very possible. And what if it's happened before in the past, right? That's the question we asked right in the beginning. Have there been alien amnesias to it? I'll go here. Has there been alien life that visited us in the past? And the question is, yeah, maybe so, you know? Could it have happened before? And the question to me was one where I said, Yeah, but you know, there's really never been any tangible evidence, or guess what? We wouldn't know about it now, we wouldn't be here. Let me say, well, we don't have to go to a conference, we know we're here. And like the congressional hearings, maybe, you know, that's a possibility. Good. Now, who saw the congressional hearing? Yeah, the most recent one, yeah. I really enjoyed it. I thought that we got more out of that. And you know what's the most important thing? The fact that it was in Congress, and the fact that the 3 people that were the witnesses were so high up in the government and in the Navy. And their word was taken as their version of the truth of what happened. And that's 3 people, and there's tens of thousands behind them that buy it. I've got stories all over the place. You know, one of the things that they have a visual effects company. I do a lot of work in the Navy, so I've done special projects for them for decades. And I can tell you, I've seen weird things that are ours that get mistaken for UFOs all the time. But there are certain things that get seen that just don't fit any of those molds or any of those current technologies. And we'll get to one of those a little bit later. So we don't have any tangible evidence that they've been here. We just have a lot of anecdotal stories. But there's circumstantial evidence. Some of that evidence comes from very far away. Here's one case. 5,000 years ago in northern Australia, the Kimberley region of Australia, we find pictographs on cave walls. Who knows what these are? Right? It's a longina. Remember the longina? Remember the longina?
Aborigines.
I'm very interactive, so don't talk about facility, and you know I know what I'm talking about, my kids. Okay? But these are the longina, and this is how they portray. They're portrayed with black eyes, little noses, no mouth, and a halo. Where have you seen a halo before? Renaissance paintings, right?
Yeah.
And the halo, it's a whole other lecture. The halo is actually throughout cultures across the world. Why do they put halos around their deities? That's a whole other thing. They do it because they probably observed it at one point. Yeah, I'll let you think about that one. So, the longina were rumored to have come from the sky, lived in the water, but have full mastery of the water. And the myth proceeds that 2 boys tortured an owl one time, and they tortured it to death. And in retribution, the longina destroyed their village. That's the myth. Okay? There is a record of a tsunami in that region. So could this have been a myth built around a tsunami? Yeah. Okay. And then, you know, every one of you that had experiences could have all had something different too, right? You can't say it's not true. Hey, come on, right? Too many of you have had experiences. So when the Wandjina wiped out their village, they wiped it out because of the torturing of this owl to death. Well, it wasn't an owl, right? An owl has often been mistaken for a threat. Okay? It's called the screen memory. It's something in MUFON I've encountered. It's something as an astronomer I've encountered. I had this happen to me. Now, science guys like me, we don't have these things happen to us until they do. And then what do you do? Well, I gotta rethink my science now, because holy cow, I've got to think about all this new science that's out there that I potentially don't understand. And so I'm probably one of the few that's open-minded to mention that, hey, I think that this could be happening out there, right? Avi loves another one. Yeah, I work with Avi on productions and stuff like that. And Avi feels the same way. He says we can't dismiss the possibility that this might be extraterrestrial in nature. Isn't this exciting? You know, look at me excited. I know, it's after lunch. I'm that guy. You know, dance. So, the truth is, okay, when we look at stuff like this, we have to consider, all right, well, if there's alien life here, if they visit us, if they're still here, and I think that the answers to that is they are. Okay? The question is, how would they recognize us from so far away? And how would we be of any interest to them? okay? We have to find Earth-like worlds ourselves, right? We're looking for them. Why? We're curious. We're curious. We want to see if there's someone else like us out there. And so we look. And what we're looking for are worlds that are both habitable, in the habitable zone, not too hot, not too cold, based on their star, where liquid water can form on the surface. And if liquid water can form on the surface, that means that the star itself is probably a little more stable than most. There's some stars out there that you just don't want to visit. Okay, they pump out radiation that would wipe you off the face of the planet. They and then be gone. Okay, but there are stars that have just the right amount of light, heat, radiation, and that's kind of like our sun. But get this, even our sun is not the best star for life. It isn't. We are not what's called a super habitable world. Well, we're a habitable world, but not super habitable. Super habitable means probably no plate tectonics, probably no earthquakes, probably no tornadoes. Nice weather all the time, you know. Maybe we're tidally locked. We have the same face of the planet facing the star as it goes around. So on the daylight side, you can go to the beach 24 hours a day. On the sunset side, you can go view the sunset 24 hours a day. And on the dark side, you can set up a telescope 24 hours a day. Oh yeah, I'm sorry. The point though is that in such a place, maybe life will develop. And if it does, it's not going to look like us. And we look the way we look, based on all those characteristics, all right, through 5 major extinction events that have happened on this planet. So we came out soft and pink, effectively, inside, because of those extinction events. Now, that process likely wasn't repeated on other worlds, right? So, the habitable zone is that place where we can survive as humans, okay? The temperatures are very mild, and the pressure within an atmosphere that's suitable for carbon-based life like us is thick enough that liquid water can form on the surface. There was liquid water on Mars, remember? Yeah, you don't remember because it never was in our lifetime. But billions of years ago, Mars had lots of water. In fact, much of the water was used to carve a lot of the features we see on Mars now. Okay? But that water went away through reasons that are yet another lecture. Okay? And the process, you know, through our solar system is that Mars is just near the outside edge of our habitable zone. And Venus, believe it or not, with 900-degree surface temperatures and an atmosphere that's 90 times denser than ours, okay, is right at the inside edge of the habitable zone. Technically, both of those planets could be habitable. They're just slightly closer and slightly further away from the sun. So, if that was the case, we might have 3 habitable planets with 3 sets of life on them, but they all look different. No? So, all of it would depend on whether the star is stable. There's a lot of stars out there that pump out incredible amounts of radiation, like I said. And we're lucky that we don't live on any of those. But just quickly, we have this diagram which we use in astronomy to delineate the different types of stars. The hottest and bluest are the O stars, and then all the way down the southern end are the coolest, really cool, okay, like 3,000 Kelvin, 2,500 Kelvin is what we call the temperature scale. And low temperature, and they're also very small. Stars down here are only slightly bigger than the planet Jupiter. And they're really interesting because those stars have the most planets around them more than any other star in the universe. So most likely, if there's life, it developed on one of those planets around those stars. Okay? So that's the interesting thing about those M-type stars. And then on the side, that's the brightness, you know, the luminosity. You see the 1, and then the sun is in the middle. Why am I giving you this diagram? Just to point out something to you, and that is that most of the stars that we see, all right, are in the type A through M. Okay? So, fairly hotter than the sun, and to very, very much cooler than the sun and smaller. All right? So, these are the stars where planets can exist. exist, possibly on an A star, maybe on an F with a little cooler than an A. And G, we know, because we're a G star. We're a G2. There's 0 to 9, G2, that's what okay. Okay. And then the M stars, of course, we can probably see life around those at some point too. I remember having an argument with the director of my observatory when I was getting my degree in astronomy. And I told him, I think it's a populated universe. And that, as Daniel said, that became the title of my book later, because it influenced me so much. And he said to me, he goes, why do you think so? And I said, well, we're bilateral symmetry, we're carbon. And I went through a whole bunch of arguments about why life is probably the reality and not the exception, right? And he looked at me, and he goes, big guy with suspenders, looked over your glass like this. He said, Mr. D'Antonio, get back in the observatory on your project and leave Captain Kirk to us. No, okay, Mark. And I walked away. Years later, the first planet was confirmed. And guess where I went? I went right back to his office, and I said, I looked at him, he was on the phone, and all I did was peek him with a smile on my face. Years later now, years later, and he looked up and he got his phone, he curls the procedure and goes, it was only one planet. I won. Right? Cool. So that particular planet was discovered around, I think, an A star. So it's actually really interesting. Now, this nasty old thing, this is the periodic table. You're made of stuff that was made in the hearts of stars once. Okay? The color coding tells you all the different elements, how they were made. Okay? And the ones that are interesting are the ones in the green, dying low-mass stars. Our sun's a low-mass star. And as it's going through its life, it's actually making those elements in its core through a process called the S process, slow process. Don't worry about it. But this is where the elements in our periodic table come from. And when stars die, they expel through various means all of these chemistry elements into the interstellar medium, where they gather and move around the galaxy in a primordial soup of life-creating elements. And guess which element is the most common? Hydrogen. I heard it. What's the second most abundant one? Who knows? Helium in the back. You should know here. That was really good at helium. The next one, believe it or not, who knows that one? Did you say oxygen? You need a freaking cookie. Yes, oxygen is the third most abundant, and carbon. You said it over here, carbon is the fourth most abundant. So it stands to reason we're going to see a lot of carbon, we're going to see a lot of oxygen, we're going to see a lot of helium, we're going to see a lot of hydrogen. And stars are made of hydrogen to begin with. Okay, but the carbon here, carbon is extremely flexible. It bonds with more things than any other element in the periodic table. It makes more compounds than any other element. Now, that vertical column in the periodic table, no, this isn't biology class, so I'm not going to go through it. But, okay, but underneath carbon is the silicon. People say, well, what about silicon-based life? What do you think of that? Silicon life was the thought process. The trouble with silicon is it makes very robust bonds. Very robust. They don't like to be broken. Okay? So if it makes bonds, and it makes fewer than carbon by several magnitudes, then you're not going to be able to have the flexibility required for your life. Right now, as you're sitting here, your body is breaking down and making bonds in order to extract energy from the food you've all eaten and falling asleep in here with. Okay? Don't worry, I slap the floor really loud and do a book like that. So when you see silicon, that's really tough stuff, and it doesn't like to break the bonds. And here's something you can use in your friends. Next time you go to the beach, tell them you're walking on mostly gas. Did you know that? What? I'm walking on sand. What's sand? It's a silicon atom and two oxygen atoms. Oxygen's gas. Yeah, got you. And they'll be like, wow. So silicon dioxide is sand. You can use that. I don't mind. No royalties needed. It's a lot of fun. So now we want to find planets out there around other stars, and the planets are made from all those elements we just saw that have been spewed out by stars. Okay? When we're going to find planets, we use things like the Kepler Space Telescope. It was launched in 2009, and sensor on the telescope. And it's a very fancy system with lots and lots of detail and lots of motion correcting systems, lots of targeting camera equipment on it. It actually takes some beautiful, beautiful imagery and detects the brightness change in the stars. And that brightness change is called the transit. Now, the universe is over which way? It's this way, that way. I mean, stars can be any way. Planets are stars can go this way, that way, this way, weird ways, okay? And only that small fraction where the star passes behind the planet, or the planet passes in front of the stars that's going around, that's the only ones we see, all right? So we call those transits. We see the starlight dim imperceptibly. Now, to give you an idea of what we're talking about, if you take a quarter, 25 centimeters, and you move it 700 miles away, that's what the diameter of the nearest star would look like in a telescope. You could actually see the diameter. And we can see when something 100 times smaller than that passes in front of that star. So we're pretty good, all right? And that was the Kepler Space Telescope's capability. Not only that, okay, the Kepler Space Telescope was looking at a small patch of sky about the size of a fist at arm's length overhead in August, okay? And that's in the constellation of Cygnus the Swan. And what it saw up there was over 2,000 exoplanets, and that number has actually continued up to over 5,000, okay? So that's pretty interesting how that's happened. And there's even more coming, and more secrets. Now, another method that we use is something called radial velocity. When something comes towards you, it gets higher pitch. And when it goes away from you, it gets lower. Okay? Now, in terms of sound, you've heard it. Train goes by. Right? Car goes by. The horn. Here. What is that? It's called Doppler shift. As the sound waves are crunched up as it approaches at a higher frequency. So it's and as it goes away, they get longer as they get dragged out behind the car. Conceptually, that's what it's like. But with light, you don't hear sound, but you see color. And the color that changes in light is the color, say it's white, it goes toward the blue end of the spectrum. As it's approaching, and when it goes away, it's the red end of the spectrum. And we see that with everything we see in the universe. We can tell whether it's coming or going, right, in a variety of ways. And that coming or going helps us greatly. If we look at a star, if we see a star coming and going, there might be something invisible moving around it that we can't see. Maybe it's a planet that's not in our line of sight. We're kind of down here doing this. And we won't see it. But we'll see the star doing this. Just a little bit as it's coming towards us and going away from us. Because just like you can take a little kid and swing him around, okay? That little kid you swing around, you're not standing straight up. You're leaning back so that you don't fall. And so that's effectively like the star. The star is going to also be moving a little bit and wobble as it's effectively leaning back as the gravity of the other planets tug on it just a little bit. And that's called radial velocity, and that's the thing that we can detect. Now, we also can do direct imaging. I talked to the Mauna Kea Observatory, I talked to the Gemini telescope guys, and we should use this. It's also in publications, also it doesn't matter. This is the first visual shot of an actual planet going to another star. The black disk you see, not a black hole. It's called an occulting disk. It blocks the brightness of the star. Because if it wasn't there, the star's brightness would be 50 times bigger than the image in all directions. So that's how small this is. And that farthest planet is several times the distance to Neptune. Okay, at the distance the star is from. So it doesn't tell you much, but it shows you we can see direct images of things. We can also measure positions of stars in the sky. They might move a little bit. Okay? And one of the programs I worked on in observatory, big observatory, was an astrometry program. We did parallax studies. We looked for nearby stars. And as the Earth was on this side of its orbit, and we look at a distance, we see a star. And then the stars behind it, watching on this side of our orbit, look at that same star, it shifted against the background. But you know exactly what that is. You hold out your finger and blink your eyes, your finger shifts against the farther background. That's parallax. On a large scale of astronomy, we actually can do that and see exactly how far away stars are. So I worked on the parallax program for years. It was great, you know. but not so great when it was 10 degrees in the observatory, you know. So the other thing is gravitational microlensing, and the gravity of something between you and a distant object you're looking at might bend light in such a way as to help you see what's out there, and you can actually detect planets or other stars in that way. So it's pretty cool. You can detect the gravity of a distant planet that's actually affecting you, all right, and then causing you to see that planetary influence on your data. So anyway, if you're interested in exoplanets, planets on other stars, one of my specialty, you can go to the Open Exoplanet Catalog. You can also get a application on your iPhones, possibly even Android, by Hannah Rain called Exoplanet. And this is fantastic because he keeps it updated all the time. All right? And it's a really good thing to use to learn about the latest planets. You get the latest counts, you can see images of what you think, the orbits, all that stuff. And it turns out there's a lot of planets in the habitable zone out there. Here we go. Habitable zone. You're gonna love it. Because that's the only place carbon-based life can probably exist. It's in the habitable zone. Now, when Kepler died, it came back as K2. They fixed a problem that made Kepler impossible to use, and they made it work again. And now we're up to 5,483 planets that have been cataloged and confirmed. Now, had my observatory director not passed away a long time ago, I would be going into his office again and saying, ah! And he would go, and it's only 5,400 planets. You can imagine. But it's all good. So the conclusions are that we might have as many, as it says, 40 billion Earth-sized planets, and they could also be in habitable zones. This is in our galaxy, by the way. And there's also 2 trillion other galaxies. Did he say 2 trillion? Yes, he did. 2 trillion other galaxies. Now, that number doesn't really mean much to you, because you can't really imagine 1,000 of anything. Fair. Humans can't do that. You didn't evolve to be able to recognize 1,000 things right offhand, right? You know? So it's hard to imagine that, right? But 2 trillion is big. And if we have, say, 40 billion, let's say there's only 25 million planets in our galaxy that are habitable and that have life on them. Okay, multiply that. Our galaxy is not really that large. The Andromeda galaxy is heading right for us, actually. And it's going to be here in a couple billion years. Not to worry. It's going to pass through and not even know it happened. Okay? And when that happens, that galaxy has 1 trillion stars in it itself. We only have 100 billion. So we're not even close to 1 trillion yet. All right? And there's galaxies that dwarf the Andromeda galaxy, and there's galaxies that make our Earth big. So there's 2 trillion others. So the prospects of life are amazing. But the question becomes, how come we are so visible to alien life? And why would we be? There's a lot of skeptics out there that say things like, oh, you know, they're not here. How do they find us in the vastness of the universe? I don't know. How have we found all the exoplanets we look for? We did a concerted survey, right? Kepler, 5,483. We're going to spot that big over your head. In a summertime constellation called Cygnus. Whoa, well, that's pretty good. So I'm sure an advanced species with time to spare, even if only 1,000 years ahead, 1,000 years ahead of us in development, would certainly have figured out a way to look for life in the universe. Why would they find it here? Why would they look here? Well, that's the other thing, okay? We are just a pale blue dot. That's that blue dot right there. You can't see it? I can. Okay? It's a pale blue dot, and my favorite astronomer, Carl Sagan, said, you're a pale blue dot in the universe. Okay? I love Carl Sagan, he's fantastic. And as a pale blue dot, what would make us stand out? Well, that guy. Number 8 in the periodic table, oxygen. Oxygen is so important because carbon-based life, like we are, requires oxygen. Our DNA is filled with oxygen compounds that and actually oxygen amines. All the things that we have within our bodies that make us up require oxygen. We get energy from oxygen. Plants generate oxygen, right? So when we talk talk about oxygen on our planet, we have to go back 2.5 billion years. 2.5 billion years ago, we had what's called the Great Oxygenation Event. Okay? That's when oxygen built up in our atmosphere, started building up. And probably about 2 billion years ago, it was probably high enough for an alien species worth the salt to see. Right? So, if they were 1,000 years ahead of us, they probably would have started looking sooner than we have. And they would have seen the oxygen in the atmosphere of this weird planet around that star. And, as you'll see, they probably would have used technology to make their way here. Now, oxygen is generated by photosynthetic organisms in the ocean called phytoplankton. It's also generated by geological processes that, can put some oxygen into an atmosphere. We see it in exoplanets that are way too hot for life. Okay? But still, it doesn't matter. The thing that's key to understand here is that oxygen is a life-giving substance to carbon-based life. So if we see it, then we know that there might be life on our planet. And so if an alien race is watching Earth over like 100 years or so, and they look at our planet, they'll say, hey, I see oxygen in this atmosphere. What does it mean? It means that there's probably life there. Oh, well, we're carbon-based too. I'm going to tell you right now, and I don't care what anyone says, I'm a carbon bigot. Yes, I agree. I'm sorry, but I am a carbon bigot. I believe that carbon is probably the predominant mechanism, if not the only mechanism, for life in the universe. As I said, carbon is the most flexible system, flexible element, can make more compounds than anything else. I think oxygen is one of the key ingredients to carbon-based life. So if you're a carbon-based life form, you're going to go looking for oxygen in an atmosphere. It goes without saying. So life in an atmosphere is something that's very important for us to find. An oxygen atmosphere. James Webb can't see it directly. When you look at a spectrum of light, the chemical elements make lines in the spectrum. And by looking at those lines, you can tell what's there. Okay? I spent years making spectra of things to try and see stuff and figure out what's in a star, what's in other thing, what's in planets, what's in the atmosphere of Neptune and Uranus. Okay? And one of the things that's important is that the James Webb Space Telescope sees in the infrared. So, if this is the visible spectrum, we see from here to here. Oxygen's in here, toward the red end, okay? We see the lines there. But James Webb sees way out here. Oh, so how are we going to see oxygen? It's over here. How do we do that? Well, oxygen has collided with each other in planetary atmospheres. When that happens, they give off a signal that's visible out here. So there's James Webb's looking for this signal, the colliding oxygen atom. And so we'll know that there's oxygen in an exoplanet in ways and with accuracy we've never seen before. So that's where we're going with this. This is fantastic, okay? But now, that all being the case, if we have an alien race that sees we're here, let's assume they are. And they find us and they say, hey, there's creatures here, let's go check them out. How are they going to get here? What kind of tech would they have to use to get here? Who's heard of the Alcubierre drive? Right? That's the warp drive that was found in 1994. That's actually not even a good enough method. That would get us to Alpha Centauri in as little as 5 days. Right? Now, at the fastest possible speed, Alpha Centauri, what we know now, is 10 to 12,000 years away. At the fastest possible speed we've ever gone. So that's not going to work. I mean, I need a bathroom break. Okay? But the truth is that if you look at the developments, the Alcubierre drive will get there in 5 days. But that's too slow if you want to visit a galaxy that's 100,000 light years across. How would you get there? You need something more. And that something more has to do with the fundamental forces in the universe. And we're not going to go through quantum mechanics and make you believe all this stuff and understand stuff. But I want you to just see one thing. These are the four fundamental forces: the weak force, the strong force, electromagnetic, and gravity. We're going to stay at this. We're going to stay looking at gravity. Okay. Now, the weak force is why you're here, because the weak force has allowed things like neutrons, which get trapped in atoms sometimes, remember that periodic table? Okay? It allows a neutron to change into a proton. So carbon atoms can change into oxygen atoms, okay? And so forth and so on. Now, that means that stars that can do that process will generate more elements in their stellar interiors. Our sun's doing it, okay? Well, anyway, and a strong force holds the nuclei together. Interesting thing about the strong force. They found that a nucleus can only be so large before the strong force can't hold that nucleus together anymore. That's what that is, okay? And that number is more as 118. And that's how many elements we have in our periodic table right now. So will there be an element 119? It might be a transitional temporary element, but right now, you don't see any way that there could be a 119, 120, 125, okay? And that brings us to light, electromagnetic radiation. And all these things can be described as usually something called a wave or a particle. Except that this one, gravity, can only be described so far as a wave. And before that, we didn't even know that. Until we saw gravitational waves, we had no idea that they were waves. Einstein said, we'll never see waves, gravity waves. He was wrong. One time, okay? But if you look at the gravity waves that we see coming from things out in space, that implies there's got to be gravitational particles, gravitons, like light has photons, and it's also a wave. That's called the dual nature of light. Well, these things can all be described with waves and or particles. What about that? It just doesn't fit. It doesn't really fit our standard model too well. And the graviton is not seen yet. That's a big problem. Or is it? You know I wasn't going to let you say that, right? So, when we talk about what alien races might use, we have to travel into a theory, again, at the lay level, called string theory. Who's heard of string theory? Not the show. No. String theory is interesting. If you think about this, okay? Think about the fact that we talk about particles like protons, electrons, muons, gluons, and so on. Okay? If we have protons, they're vibrating. Everything is vibrating. Right? Doing this. And we have a proton. This and a proton at that. And what's in between? The path we took to go back and forth, right? That's the string. Okay? It's a different way of thinking now, but that opens up a whole host of possibilities to how aliens can actually travel through interstellar space. When I say travel through, I don't even mean that. Ooh, this is going to get weird. But stick with me, because you're going to like this. And I trust this will be something you're going to want to remember, all right, and move forward with it. This gives you the armament to say, I know how they're here. I don't just have to believe they're here, I know how they got here. Because this is the only way they can do it, in my view, and well, in other people's views as well. Okay. Now, in string theory, we talk about things called membranes. Don't worry about the names, but we know that we're in a three-dimensional world. It's actually four dimensions. We have X, Y, and Z all moving time. Okay. My hand here, only got here because of time passage. It's still in the three dimensions. It didn't change, but time passed, and so it moved. That's how we describe an object that's in the four dimensions. Okay? And that's our home membrane in string theory. But the thing that's interesting is that when we talk about that being our membrane, and we go into a theory about string theory, one of the variations of string theory is called Randall-Sundrum 1, RS1. Again, names don't mean anything. It's just a concept here. This is the one that's most exciting. And the reason is because we have our membrane, our four-dimensional moving through time. We have another one called the bulk, like bulk produce. What the heck is that? And we'll share that. And then we have an outer membrane that borders that in this construction called the plant membrane. Now, again, string theory has not been proven, but Michio Kaku adheres to this, okay? And other scientists, other astrophysicists adhere to this, all right? But they're cautious because we haven't been able to prove it yet, but we will. Just like we haven't found gravitons yet, but we will. Now, when we look at the shape of a UFO, okay, Why are they round? Why are they triangular? Ever question that? Why did the term flying saucer ever get coined? Why are they saucers? What's going on there? There's something about them that's very interesting. That very interesting thing could be because the nature of how they travel requires them to be that shape. And that, I think, is a key element here. Okay? And we'll talk about why it's true that these objects are actually particle accelerators. Have you ever seen a particle accelerator we built? What are they? What shape? Oh yeah, right here. Rings, aren't they? Now, we make big rings, okay? We make giant rings, okay? And we use this ring to generate these particles and collide particles together to make other particles and see what they produce. But I think that alien life has decided a way, or figured out a way, to shrink their accelerators down to just about 30 feet in diameter. It's kind of like the average dimension of a UFO. Now, what does that mean? Well, we look at rings. This is a small one. Okay, we're looking over 25 miles across for the CERN super collider, a large hadron collider overseas. Okay, and that's how big the ring has to be. The trouble is, as they try to constrain particles to go in a circle, they do it through very, very powerful magnetic fields to kind of shift those particles into a curve and keep it in like an orbit around that ring. And when they do that, they give off things, radiation called synchrotron radiation, which you see right there, which is deadly. So I think an alien race would have also had to solve that problem as well if they're expected to use this technology. And what technology am I talking about? Well, these craft, I believe, generate particles that live in that Hall space. Now, what does that mean? Those particles are called collision-klein gravitons, collision-klein particles. Interestingly enough, CERN is building another accelerator right now as we speak. Guess what they're investigating? Those guys. They're building because collision-klein particles seem very interesting for some reason. Wonder why. I know why. I think. Okay, and so do a lot of other people in physics and natural physics. Okay, it's because those particles are the key to getting around the darn universe. And we'll see why. Now, as a graviton, these collision-klein gravitons are 10 to the 16th times more powerful than the ones holding you in your seat right now. You know, and holding those 4 people sound asleep on their desk. Kid. It's always but at that kind of power, right, what's going to happen? How do these gravitons operate on a ship if it's generating them? And what generates them? We'll get to that. Okay? But these KK gravitons, as they're called, also generate micro black holes, in theory. Now, a micro black hole is, of course, a small black hole. They are theorized to exist, and we think they do exist. But they don't live long. They don't last a few nanoseconds at best. And then they evaporate. All black holes are evaporating, all of them. They're giving off a lot of energy from their collapse, and they finally evaporate away. Okay? And that evaporation process is exceedingly quick with the smaller black holes. So this one, with the smaller micro black holes, is nanoseconds, billions of a second that they live. So what good is that? It's very helpful if you keep generating these micro black holes and surround your ship with them. Now why would we do that? Because those KK gravitons live out in that 5th dimension, that bulk. So what good is that? Well, we're going to see. Okay, when you generate these particles that live in the bulk, some magic happens, right? Those micro black holes decay almost instantaneously, all right? But when they decay, new ones are replacing them. So you have these KK gravitons and you have these micro black holes. And when this happens, okay, the micro black holes absorb the Earth gravitons that are holding a ship down to the planet. Sound like anti-gravity to you? It is. The absorption of micro black holes, our Earth gravitons, will prevent the ship from feeling gravity from the Earth. Whoa, that's magic, right? But it's not. It's physics. Physics. And it could likely exist. This is, again, a theoretical construct that may very well exist. Now, the other thing is, if the ship is not subject to gravity, you can just go any which way it wants, sort of float. How many times have you heard of a flying saucer floating like a leaf on the wind? Right? You've heard that. Well, that's kind of like this, and that might be because of that process that's in play. Right? Now, the other thing is, the KK gravitons pull the ship into that bulk space, that fifth dimension. We have 4 dimensions, and we have a 5th dimension out here. What's different about that 5th dimension? That 5th dimension is really interesting. It's highly worked. If you go in there, the distances within that dimension are much smaller. So the universe is a smaller place. The farther you go, the more KK gravitons you make. The farther you go, the closer the universe becomes. Make a few, you go in a little bit. Okay? Make many, you go in a lot of it. And that lot of bit translates to a very strong potential to go and punch back in a place that's much farther from where you once were. So, if you want to put Alpha Centauri in your spacecraft, you're going to generate these KK gravitons, and you're going to generate lots of them. You're going to go far into that 5th dimensional space. And then when you come back out, you have the potential now to go much greater distance. And I call it a punch-out, punch-in process. They punch out to our 4 dimensions, go into the bulk, however far they wish to go, and then punch back in, however far they wish to go. Now, the more energy they use to do that, the more particles they make, the farther they can go. It really is a simple equation in the end. And so these particles then will allow them to literally punch out of our 4 dimensions and disappear from your sight and punch back in somewhere else. In reality, they probably oscillate. They go back and forth, probably many times per second. I was on a U.S. submarine decades ago, notice the plural, decades. Not a sailor, because I was just on a doing a project. Navy invited me to go. I've done work for the Navy in the past. And I went for this ride, and the most probably had me seasick. Don't lie. And I was sitting in the sonar area in the ship called the sonar shack, trying to get my stomach back. It didn't feel good. And not get sick on the captain. When we went to the wardroom later for dinner, really, I had sick and didn't think I had to eat after that. Well, anyway, I'm sitting there in the sonar room and I'm drifting off because the sub's noisy, you can't hear yourself from there because the din of people talking and sounds and high pressure air and instrumentation moving and chirping. You can't hear anything. It's like, it's a constant din of noise, white noise all the time. So that was actually helpful because I was sitting back in this one chair to the left of the active sonar that the kid was on. Okay? And there were 2 more stations to my left. And I was sitting in the second one. I was getting my stomach back, closed my eyes, and as I was drifting off to sleep, all of a sudden I heard, con sonar, fast mover. Oh, what? I wake up, blink. I'm wide awake thinking, oh no, it's a torpedo. I've been sick of looking for this ride. I'm going to die out here. I thought it was over. I really did. Okay? I won't tell you what else happened because that's embarrassing. But the fact is, and a submarine, everybody knows it. Okay? So, the bottom line was the executive officer comes strolling around. Okay, what do you got? Little emergency, please. They were going to be by a torpedo. That's where I was going in my head. And the kid tells them they're very in the range. I'm sitting next to him, so the kid's here facing the executive officer, the executive officer's here facing the kid. I hear what he says. I don't really hear what he's saying too well. So I didn't get the bearing in the range. Okay? And I couldn't read the waterfalls play to say what it was, because it was there, it was gone. And I'm sitting here on the edge of my seat like this, thinking what like I do every day. Well, I'm just relaxing, listening, trying to hear. And then the executive officer over here goes, how fast was that moving? And the kid literally turns sideways, puts his hands out like this, just like this, and says, loud enough for not just me here, but for almost anyone here, to several hundred knots, sir. Now, sonar guys on the boat have to have the ability to classify every single thing they see. So if you can't, it's it's like, you know, it's a failure. And holding his hands out is a sign of I don't know what to do. Basically, I'm scared you're gonna, you know, be mad at me because I don't know how to classify this. And he held his hands out there for like, let's see, an endless amount of time, after saying several hundred knots, underwater, for an object that was next to silent. And the ex-executive officer said, okay, log it and log it. So yes, sir, he went back to work. Me, Mr. Important Guy, VIP in our boat, that's right. I get up, I'm getting answers. XO, can you tell me, sir, thank you, nice to see you. Can you tell me a little more about this fast mover? I know all about them, I can probably help you. He goes, yeah, Antonio, right? Oh, sir, yes, sir. You having a good trip so far? Sir, yes, sir. Let's keep it that way. That's how it happened. And then I went back and I sat in that sonar seat. My seasickness is gone, man. I was just frightened to think I was about to die. And I am now exhilarated. I can't wait to get off the boat. But I want to go back and start researching this stuff. So I eventually got off the boat, and several years later, I actually had to do a job with Joint Chiefs. Big guys. So I drove down to Washington with this particular classified project. I delivered it, and I asked the guy who, very important that he was naval, put it that way. I said, so what can you tell me about the fast mover program? I shouldn't have said that. In my brain, I was like, don't ask, and the words were going, come out. And he could have said, I have no idea what you're talking about, or he could have said, take him away, off the level work with him, or whatever. But instead, he looked at me and goes, oh, I'm sorry, Mark, I can't talk about that program. I won't tell you about the embarrassing thing that happened just then, too. Okay? But you can guess. And I'm telling you, I go all the way back from Washington to Connecticut, where I live, like this. It's real. It's real. I can't get it. Oh, there's the truck. Watch the road. I literally was not on top of my game driving back, I can tell you that. So, the question is, how do they do that underwater? The only way that would actually work is this way. And if they oscillate, like I mentioned, back and forth between our four dimensions and that fifth dimension, then they're not really here, they're not really there. So by going fast enough, they could be moving fast through water and not even feel the effects of water, not even really be there. Why is that? Because, and this is the most important feature of this, when they punch out and they move into that fifth dimension, right, they punch back in slightly further ahead from where they were. These ships don't have propulsion, they don't have engines. They don't need them. They punch out and punch in. They just move, they punch in at slightly further distances away from where they previously were. And have all these little jumps in together, and it looks like a line. That's what showed up on the sonar. Punch in, punch in, punch in, punch in, punch in, punch in. All the way across that particular location in the ocean they were. This was the North Atlantic. So now, that process is how they operate in my view. They oscillate back and forth between this fifth dimension and our four dimensions. And that's just a natural process that's occurring that has been worked into their hardware as they make this stuff. And I'm telling you, by doing that, they don't have to be subject to the physics of the medium that they're in. They can be in water and not even know it's water. They can be down there the whole time. They can be in the deepest part of the ocean, just oscillating back and forth. And they're not going to feel the pressure of the water. They're not going to feel anything at all. The temperature varies, oscillating back and forth. And they can be, and in the time when they do this, you think, well, you know, you say how fast the UFOs move. Move so fast, nothing can handle the forces of this kind of movement through the ocean or through the air. Well, if you're in a big ship the size of this room, or doing that, it would feel like this. You wouldn't even know you were moving. You wouldn't feel a single bit of motion. Why? You punch out into the fifth dimension, and then you punch in a different location. You're traveling to discrete points. This one, this one, this one, this one, from a common point. You're not moving there. You're just dimensionally shifting to the fifth dimension, and then dimensionally shifting back to our fourth. And that is seamless. You don't feel it. You wouldn't even know you were doing it. You're doing it right now. You wouldn't even know it. So that is, I believe, how this is all working. This is how it works for me. So when you look okay? When you're inside that bulk space, time is really shortened for you. It's slowed down. And the universe being so close to you gives you options to punch in wherever you want. So in my view, an alien species, 1,000 years ahead of us, they're probably the greatest cartographers the universe has ever known. They know all the punch out and punch in locations. You don't want to punch in the middle of a star out here. Kind of ruin your day. However, at the speed that they're doing it, with the way they're doing it, they might actually be able to do that without consequence, depending on how fast they're doing it and how far in they go. So it's pretty cool. So here's what I think. When you look at let's say there's a UFO using this technology, a UFO will look like its colors are shimmering. It'll be rapidly color changing in the sky. It'll also look like it's fading in and out. Your eye. It'll also look like it's overtly vanishing and reappearing in a wholly different area in the sky. Now, as an astronomer, I can tell you, okay, that first one, I would call it atmospheric scintillation. We have a star with a rising colors, so it's a green changing color, right? Sirius is a great example of that in the northern hemisphere. It'll look like it's changing color. It can be that, right? Yes. Fading in and out. It's at the extent of your vision. Sometimes you see it, sometimes you don't. Okay, people seeing faint but bright objects, sometimes that's what happens to them. Okay? It can also look like it's overtly vanishing from here and reappearing over here. And that could be something called the autokinetic effect. Your eyes are no good at following things in the sky. It does this. Okay? So when you see something in the sky, it looks like, it could look like it's moving around all over the sky, yet it's moving in a straight line. Okay? And that's the autokinetic effect. However, we can't dismiss the possibility that what we're looking at is evidence that we're seeing KK gravitons in action, can we? Can't dismiss it. And it's actually probably somewhat likely. Oh, that's scary but fun. I like that idea. So the question is, when we talk about this, right? Well, I should say the verdict first is that UFOs move by using massive gravitational fields. They create these massive gravitational fields, and thus they can punch out and punch in many times in a row and to discrete locations. Now, you don't have to go very far into the bulk to then punch in, say, over here, a few feet later. Okay, or over here. You want to go a long distance, like to the moon, or you go a little farther in, you go to the solar system somewhere, or you might go to opposites, where you go way deep into that bulk to get the work that you need to get out and punch in at far distances because you need that energy. Now you say energy, Mark, what do you mean by energy? Well, the only thing we actually need to generate these particles is something I mentioned over on this side a little earlier, right about here. I mentioned that Lawrence Livermore is working on fusion reactors, remember that? And the fusion reactions they found were, they sustained the fusion reaction. They did not get out as much energy as they put in, but they did create a sustainable fusion reaction they had to shut off to make it stop. That's interesting. Why? Because what you need to generate these magic KK particles is just a fusion reactor, which I mentioned over here, CERN is working on exploring those KK particles. So KK particles from CERN, Lawrence Livermore, building a potential fusion reactor down the line, marry them together, a marriage made in the universe, and off we go into the universe. What do you think? Isn't that cool? Yeah, when you wake up, you'll understand all of it. So, the question we ask is, where are they hiding? Well, I know that people talk about the moon being hollow, the moon rings like a bell, things like that, far side of the moon. But the fact is, we've covered the moon with the Lunar Reconnaissance Orbiter, with Japanese, JAXA organization has gone around the moon with all kinds of solar system satellites that show every square inch of the moon. And the Lunar Reconnaissance Orbiter has done that. You can go, in fact, to LRO Quick Map, so LRO, Lunar Reconnaissance Orbiter Quick Map, and you see a map of the moon, you can zoom in endlessly, right down to the level where you can see the tracks left by the Apollo astronauts on the moon. And yes, we went to the moon. I don't want to hear it. So, I grew up in that area. Okay. And the thing that's interesting is that, so the far side of the moon is out. Perpetually dark craters, that's out. We saw that we can see into those craters. Laser altimetry shows the depths of those craters. We know what's in them. And also what's out is the interior of the moon. The moon is not hollow. Now, I know a lot of people argue about that, but let me tell you. The first thing they say when you argue that point is they say, well, the moon's not hollow. Why did it ring like a bell? Have you ever hit a hollow object with a little tiny hammer? What does it sound like? Doesn't go ping. Hollow objects don't do that. Why do bells ring? Because they're open at the bottom, and it sets up what's called a standing wave. And don't record that. It was like go back and forth, making this ring, and the sound comes out through the opening here. There's this audio cavity. Okay, so bells ring because of their construction, and it was a misnomer to say that the moon rings like a bell. It didn't ring like a bell; it rang like a solid object. Okay, for proof. You can go to Pennsylvania, let's all go right now, everybody over here. If you go to Pennsylvania, you go to Ringing Rock State Park. And in Ringing Rock State Park, you will find the most amazing thing, right? You'll find that in Ringing Rock State Park, there are rocks. They give you a hammer when you win. And you take a little hammer and hit the rocks. And they go, ding, like tuning forks. Why? They're solid. Their composition is really interesting. Being solid, they ring forever. And that is why the moon rang when things hit it. The sound waves kept bouncing back and through, unimpeded by a medium like air inside, or voids, okay? It went through a solid substance very efficiently. So that's why it rang, okay? So, in the end, when you talk about where they're hiding, when they be in the oceans, sure, I think they are. You know why? Because they go where we are not. And we are not there. Okay? Right? And remember Jeff? Remember People of Earth? Great show. Jeff was the gray, Kurt was the reptilian, and of course, the North Sky with Don. He was the Nordic. Okay? Great show. Alright? Now, the point I'm making with this is, when you look at this guy here, what kind of planet would Jeff develop on? Well, he might develop on one of those little tiny red dwarf stars we were talking about, or on a planet there, because he has eyes that might be big enough. I'm not talking about him, the actor, I'm talking about the Grays in general. Okay? They have eyes big enough to actually see in a darker area, so maybe he was on the sunset or dark side of an M-class planet, you know, or on that star. Or, he was, and of course, the lack of pigment in his skin can be because evolutionarily it wasn't naturally selected that he needs to have more than gray pigment. And that's a natural pigment that you might go through. And how about Kurt, the lizard? I struggled for years with the concept of reptilians, and then I had this epiphany one night. I woke up and I said, I'm almost done, I promise. I had an epiphany where I said, you know, we're here because of the 5 extinction events that I mentioned. What if we didn't have some of those extinction events? You know, when dinosaurs died 65 million years ago, the Cretaceous Paleogene mountains, called whatever, but when that happened, what if that hadn't happened? Well, I looked it up and I started to realize there were some dinosaurs at that time that were actually getting smarter. Smarter. Now that means, of course, that it's possible that they could have reached some type of intelligence at some point. You know? But intelligence isn't a foregone conclusion. It's a possible destination, no guarantees. I mean, you know, even now, with every human on this planet, you can certainly point to a whole bunch of them that just aren't that intelligent, probably. And some of my friends, they also question, you know. I think I have a dog that's smarter than at least one of my friends, anyway. But I won't tell Bob that. Oh, no. But the point being, you know, so it's not a foregone conclusion that we reach intelligence, right? But a planet like this. time the dinosaurs died was actually increasing its cranial capacity quite rapidly. All right, Troodon, Troodon. And so if you look it up, you'll see. And the Troodon is a very interesting dinosaur for that reason. But again, it's not a potential intellect. Maybe it'll then become smart as a dog or a porpoise and never get quite smarter than that. We won't know, will we? More life species have died on this planet than exist. All right, and so and of course that's because of the variability of our planet and the fact that it's not super habitable. If it was super habitable, then we would be probably surrounded by less species, but more robust species. Why less? Because the ultraviolet radiation from our sun, time and time again, has mutated the genetics in a lot of creatures, causing them to be different next generation. And if that turned out to be something beneficial to their survival, it stuck around. The ones that weren't died off. So automatically it weeds out the less capable and heads us going toward the more capable. Right? So in any case, look over your shoulder and make sure that these guys aren't there. I actually get spooked by this because I had an experience just like this. I had what I think might have been an implant shoved up my sinus cavity over 3 nights. It was frightening. I went to a surgeon in Harvard, Connecticut. He took it out. And it proceeded to vanish a week later from the pathology department. But I never got a report. And then I went back to 4 years later and discovered, after talking to the surgeon, that he had just given up his top secret clearance that year. So when you have a clearance, you have to report potential things to the NSA. I did. I had to, and it was things that were related. When I was on the side of the ufologist, I kept trying to get answers. And he didn't like it too much, but they played ball with me because I did good work. So anyway, bottom line was this doctor had a top secret clearance for me to put this thing out of my sinus. Okay? It was the size of my 2 thumbs. It stacked. And it sounds gross, but he pulled it out that little tiny hole called the nasal cavity. When he pulled it out, I felt like Arnold Schwarzenegger with right? That big ball, like in Total Recall, remember that? Oh yeah. Okay. Well, it felt like that, but I asked him right then and there, can I have that? He was like, Dad, your money was in your pocket? You know, no, I just want that. Why? And I told the story about how a creature like this seemed to shut this up, several years earlier. So I stopped being able to breathe out the side of my nose from that point forward. And in that case, what ended up happening was, he laughed, said, oh, I'm sure it's not aliens. I go, no, of course not. A week later, it was gone. And he said, you don't know what happened? He doesn't. Because as a person with top secret clearance, he called down there and said, I had a patient with this, and this, and it's not pathology now. Okay, thank you, doctor. He hung up. Plausible deniability. He has no clue where it is, and it's not a lie in the world. And so that's why he would pass a lie detector test. He would pass any court date, he would tell the truth. Plausible deniability. So anyway, that's all I got for you. And I really appreciate your attendance and so forth. But it's my first time in Edinburgh, so thank you so much. Daniel's going to be here momentarily. There he is.
Awesome. Marc, thank you so much for coming out and sharing the first time. I'm excited to have you. Guys, definitely check out the Sky Tour Live. It's going to be something you can offer, and he does on a pretty regular basis. So if you're on social media, you can follow along. He posts a lot about this, and I think it's a great opportunity for people to see and learn about the stars and learn about things that are, the way we can kind of help to sift through the noise and where it's up there that we can make sense of, that we know are satellites, or maybe it could be something else that'll, understand what we're up to.
You see a lot of different things up there. We do. So, hey, you can join us too. It's all free. We don't charge anything for it. So, thank you again, guys.